finished transcription happen, okay? And this happens because of TF2H phosphorylating that carboxyl terminal domain on RNA polymerase allows it to release its hold on 3 of those other transcription factors. Okay? But F will stay bound to RNA pol. That's the end of your TF2 and a letter saga. Are there any questions about it? Gets so much worse than this, but we're not gonna cover all the real details. You thought you knew everything about gene transcription, and now you know there's so much more. It gets really specific for different genes too. There's some genes have special factors that come in. You guys have heard and thought about transcription factors in terms of upregulating and downregulating genes. Well, as you can imagine, if you think about this complex, if you have a special protein that helps facilitate this whole thing coming together faster or at certain times in the cell cycle, et cetera, that's what we mean by transcription factors in terms of upregulating and downregulating gene expression. So that whole process, kind of up to this point where we think about, okay, now we broke contact, that's initiation. Okay? After it breaks contact and RNA pol can move forward, then it elongates. And I put a period. That's it. That's all you have to know. Right? Elongation. Termination. Okay. So elongation, you guys know enough from before. Really, for that, all you need to know is, okay, if I have a DNA sequence, I make a complementary strand for RNA, replace it with the result. Okay? There's no other specific, fancy, new things you need to learn for elongate. Okay. Any questions about initiation before we talk about termination? Which also terminates our Okay, so termination is very much, in eukaryotes, very much an area of research right now. The whole process is definitely under research. You know from the other classes that you have a poly A tail, right, on the end of the messenger RNA in eukaryotes, so that poly A tail does many things, one of which is to shovel it out of the nucleus, okay? So elongation will happen past RNA pol, will transcribe past the RNA, or the poly A tail site. And at some point, the RNA is cleaved and messenger RNA can be released. So this whole termination process is definitely an area of research and debate. But there's 2 models, and this is very general. We're not going into molecular details, but 2 models that you should kind of be aware of that exist out there for how this might be occurring. And what they really, the last time I read up on this, what they think too is happening is both models are likely occurring in eukaryotes. And it depends on the gene sequence, and we see all different kinds of ways that in eukaryote transcription can be terminated. But one would be an allosteric model. And what this means is the factors that are involved in elongation, okay, so proteins that help this process continue, somehow they release. So we're just describing these in a very general way, in a very kind of general context. We're not getting into specifics here. But elongation factors release, so that could be part of the allosteric model, or conversely, a termination factor binds somehow. So you're talking about specific proteins that make this process happen. And either one of these scenarios for the allosteric model, the result is that RNA pol 2 is going to destabilize and fall off the DNA. Okay, so that's kind of similar to what we talked about with bacterium. At some point, you have to get RNA pol off. You have to say, okay, yeah, you're done. Get off the DNA. We've finished transcribing this gene. We're done. We're at the end of the messenger RNA. We passed the poly A tail site. Your job's over. Get out of here, dude. So this happens either with the help of elongation factors falling off themselves or specific proteins that terminate somehow bind. Okay. The other proposed model has kind of a fun name. It's called the torpedo model. I think people are running out of names for processes, so they're coming up with great things. But this actually involves, it's kind of strange because it's degradation of the RNA. So there's an exonuclease that would be involved in this model. And it actually binds to, specifically to the 5' end of the RNA, the transcript. And it degrades it, moving along towards, in the direction of RNA polymerase. Okay, so RNA pol is still bound to the DNA and bound to that messenger transcript. All of a sudden, an exonuclease comes along, recognizes somehow the end of that 5' end of the RNA, and starts chewing it away, and it'll actually run into, so the reason they call it a torpedo is I think it's spiraling around that helix, and it zips up the RNA, and it knocks off RNA polymerase. Okay? So eventually that exonuclease hits the polymerase, and bumps it off the tracks. So this is kind of similar to the row-dependent mechanism that happens in prokaryotes, where you have a separate protein that's coming on and pushing off, specifically running up a strand and either degrading or traveling along it, as the case is with the row-dependent. This would actually be degrading part of the RNA. And what most folks that I've talked to think is that both of these models are happening, it's just dependent on the different genes. Yeah.
Just real quick, allosteric means like it's coming from itself, right? Sources within the DNA. That allosteric means for that name.
Allosteric, I usually associate it more with. I think of it more with.
This strange lady
you're
came in.
doing the progression, but you have a different way than keep that in your head to memorize it. Yeah.
Totally.
Yeah.
I'm
Okay.
Did the exonuclease degrade from the 5' end of the RNA when you send up without a strand of RNA at the end?
It happens after poly A tail, right? It binds after the poly A tail.
Yeah, it binds after the poly A tail. So you would. So
I
you
thought
would.
an exonuclease had to bind from the 3' end.
Yes. But you're thinking. So where are 3' RNA? Here. And your poly A tail. About your 3' end. It could still degrade part of this.
She's finally out of depression.
And you'd still have fragment left. But you're correct in thinking that it's obviously you're getting rid of some of the sequence. And so I have a hard time with the torpedo model, but I wouldn't say that to colleagues that work on this. But
You don't understand.
yes, I think in those particular genes that folks have apparently done the work that they find exonucleases in the region and attached, you must have a big area of sequence that is not necessary for translation. Obviously, yeah, you would have to. But it's a weird, kind of like small. I like this one better, but nobody will do that. chapter 12 for right now. We'll come back to some
Like
of
right
our.
now.
If you have questions, come to me.